The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. I'm obviously not Mike Clark. I'm Sharon Dooley, and I think you're going to really like our topic today. It's about query tuning, and that's always a popular subject. I'd like to thank our sponsor, Dell Software. They make it possible for us to give away the Amazon gift cards at every meeting that we have, and we are very grateful for their support. If you've not been to SQL Saturday, it's time for you to find one near you. I see I should have edited this slide since it's October 14th and the early ones are now past. It's a one-day free training event, and they're all over the world. They're somewhere near you. They are usually held in each community every year, and it's a great opportunity to hear good speakers and also to meet other people who are in your area. Summit is almost here, October 27th through 30th. I can't wait. It's my old home week for me. I get to see a lot of friends I only see once a year. Um, if you're not already registered, there's still time, and you can use our discount code to save $150. Discount code is also on our website. There will be a community zone, and I will be in the community zone on Friday, October 30th at 7 a.m. I don't know if Mike and Julie will be there. I'll try to lean on them to come so that you've heard our voices. You can actually see our faces. And we'll all three of us will be all over pass during the summit. So just look for us. We'll be wearing our badges like everybody else, so you can see us by name. Uh, we are one of many virtual chapters. Uh, I love it that you are all involved with this one, but you may find, as I do, that there are other virtual chapters that you're interested in. And so check them out on the past website, and all you have to do is sign up for them, and you'll get on their mailing list and get stuff from there about their presentations. PASS is an all-volunteer organization, um, and you can just update your profile to say what you want to volunteer for. There is an outstanding volunteer award, which is given every month to honor somebody who's nominated by their peers, and you can send your nominations to volunteer recognition at sequelpass.org. I thought I took this out. I guess I didn't. The nominations for the Passion Award are no longer open. The Passion Award is given to an outstanding volunteer, and it will be presented at the summit. And it's always interesting to see. Most of the years that I've been going to Summit, which is more than I'm going to tell you, it's been a woman who's won the Passion Award. Last year it was unusual because a Russian gentleman who certainly deserved it, was given this award. I don't know why it's usually women, but it always pleases me. And if you're not a member, sign up and become a member. is a valuable training resource, and you don't want to miss anything. Now, I'm really happy to introduce Janice Griffin. She's presented for us before, and she does a lot of SQL Saturdays, and she's has more than 25 years experience in as a DBA, and she's worked with both real-time network routing and OLTP, and she's mentored many other DBAs on best practices in database performance tuning. And Janice was actually one of the first speakers we had way back in the day when we first started out doing these presentations. And I'm delighted to have her back as a panel speaker. And I'm going to turn the meeting over to her and let her have the floor.
Hello there, everyone. Thank you. Let me get my screens up. Thank you for joining me today. And we'll just begin the slideshow now. Okay, here we go. Showing my screens. Okay, great. Okay, welcome everyone. My presentation today is on query tuning. Let's get it right the first time. And just thank you, Sharon, for introducing me. Just a little bit more about myself. I've been at SolarWinds for 8 years now. I am now considered their database performance evangelist. That's why I do a lot of talking around performance. As Sharon said, I have over 25 years of DBA experience. Primarily, I started out in Oracle. Sybase and SQL Server are my three strengths, although I'm now getting into MySQL. I've, many different database types throughout the year. Always been a DBA on the development side, and I've specialized in performance tuning. In fact, for 5 years, I had my own consulting firm doing just that. Oftentimes, especially at SolarWinds, when we get with the customers or prospective customers and look at the things in their database, I see they're paralyzed by tuning, and so this is why this presentation. People are looking for a big red button to push to fix it, and a lot of times there isn't a big red button. So this is just kind of a methodology I use in tuning, and we're going to talk about these things. We're going to talk about the challenges of tuning, who should tune, which SQLs to tune. Sometimes it's even hard to find which ones to work on. We're going to use response time analysis. It's a methodology I've used for years. To me, it's the best way to tune and to find the SQLs and actually get clues on how to tune. And then we're going to talk about gathering the details about that SQL statement once you find it. And example, query execution plans. We're going to look at how you read an execution plan, and try to find the best execution plan by using a technique I call query or SQL diagramming. And we'll use case studies to kind of walk through that. And then finally, we'll talk about monitoring to make sure it stays tuned. Okay, let's get started. The challenges of tuning. Let's face it, tuning is hard, and the reason why it's hard is because it requires a lot of expertise in many areas. Not only do you need to know how to read an execution plan, you need to know how SQL Server is going to access that data and what's the best approach for each SQL statement to go get that data off disk. That's the slowest piece of the whole computing environment is reading disk, so you want to be smart on how the SQL is going to be read. I also believe you have to know how to write good SQL. Sometimes when you're tuning, you have to rewrite the SQL. And not only that, I think it's important that you know the business aspect of why that SQL is there. What's its purpose? Who's using it? I always tell the story, but it rings true. Years ago, I worked for a manufacturing firm, and basically I was responsible for their financial databases. And every month end, just like clockwork, people would come and complain. Database is slow. And so in looking and investigating what was going on, it was these month-end reports that were being run. And when we actually found the clerk that was running it, what she was doing with them was just putting them in a drawer. She was printing them out. They're running, taking days to run, and printing them out and putting them in a file cabinet. Oh, when we started looking around, nobody was using them. They were obsolete. She'd inherited that task from, downsizing, and somebody told her to run them, and so she was running them. And so the easiest way to tune that whole thing was just to shut those off. So I think it's real important you know why that SQL is being run. Tuning takes time. Lots and large number of SQL statements, hundreds, maybe thousands of different SQL statements. Sometimes it's hard to find which ones to focus on, but not only that, each SQL statement has a different solution. There's no cookie cutter approach in tuning.
Hey,
And then
Janice,
finally, yes?
the
Yeah?
folks are saying they can't see your presentation. They can hear you.
Huh, okay. It says I'm presenting. You want to try making me presenter again, and I'll show my screen again.
Well, some people now are saying they can see it. Some people said they couldn't see mine. So I think it must be individual connections that are causing the problem. Those of you who can't see the screen, I suggest you disconnect from the meeting and reconnect and see if that helps helps, because I can't. It's individuals that are having the problem, not everybody.
Yeah, that's what I would do, is log out and log back in. Maybe that'll
And guys,
fix it.
if it doesn't work when you do that, the session is going to be recorded. It'll be at dba.sequelpass.org, end of today or first thing tomorrow. Thanks, Janice. Go ahead.
Oh, sure. Okay, Sharon. Okay, so another thing is that tuning is sometimes considered low priority in some companies because people have third-party vendor software. They don't think they can tune it, or they want to just throw hardware at it, which you really usually doesn't work. It may tune may feel like it's running good for a little while, but really poorly tuned queries will just eat up hardware and continue to do so until they're tuned. Finally, tuning is never ending, but that could be a good thing, especially become good at it, because you're going to be known as the go-to person, especially when they say the database is slow. Who should tune? This is another challenge. You'd think developers should tune because they wrote the code. However, developing applications is really difficult. Typically, they're focused on a date, a delivery date, and on functionality for the end users. So there's no time left often to tune when they're writing that code. Not only that, a lot of them use third-party code generators that create the SQL for them. They may not even know how to write SQL. And then finally, they aren't working usually in the production database, so they're not working on the same equipment, same data set, so it's really hard for them to tune. Now, you might think a DBA should tune, but they're not focused on the code like developers are. They don't know why that code is there and who's running it usually. They're more focused on keeping the lights on. Years ago, when my last job, I actually was managing 5 other DBAs, but I also had 50 instances that I was responsible for in production. Now, times that by 7 because there were 7 environments: QA, test, user acceptance, and so on and so forth. So yeah, very busy, very hard to take time to tune, because trying to keep all that and juggle all those environments together is very complex. So I feel it's best that you take a team approach. Call the tuning effort a project, and actually, get the end users, the developers, the DBAs all in the room and talk about it as a project, because really it's going to give you the biggest bang for your buck for giving resource back to the company. Which SQLs to tune? Now, this one often is seen as a challenge, but I've used these different methods throughout the years to find and focus on which SQLs should I tune. The first one is really easy. If you have an end user complaining or a batch job that you see that's running longer, then you can set about tracing that, or watching it and focusing on the SQL statements that they're either running or the batch job is calling. That one's pretty easy. But if you're just trying to sit down and tune something and make a difference, a lot of times I've used this method of querying my logical IOs and sorting my SQLs by the ones that are causing most logical IO. those, because if you think about it, every SQL statement has to do at least one logical read. Oftentimes two if it's using an index. So what's neat about that is if you can reduce the logical IOs, you can actually improve performance. Consuming CPU is another one. I'll take my high CPU queries and start on those, because if I can reduce the time spent on the CPU, I've actually freed up processing time for other SQL statements. And finally, and this is what we're going to focus on, is high response time. You can actually get from the DMVs what SQLs are running and all kinds of good information just by polling the DMVs. Now, what is response time? Well, since SQL Server 2000, basically Microsoft instrumented it so that every SQL request that goes through the database not only does 100 or 1,000 steps to get the SQL response back, but what Microsoft did was instrument SQL Server so it records off not only the time it takes, but also it records off the resource that each step is using up or waiting on. And it does this by recording wait types, and we're going to talk about them in detail. But if you were to watch each step and record off the time and the wait type that it was actually waiting on, then you could quickly organize your queries into the SQL statements that are spending the longest for your end users. The end user to get a response from the database, when they're sitting there, they're waiting, they're not actually working. So you could speed them up by speeding up the queries that they're waiting on. What are the DMVs? Well, DMVs basically are real-time in-memory tables that hold performance data. And they're going to show you sessions, they're going to show you all the sessions running, whether they're active, every step that they're doing, they're recording off the time and the wait time. They'll tell you which database they're working in, which users running at all times, of good things. But the problem with DMVs is that they are from instant startup or from the time the cache was last flushed. So there's no way to tell when those statistics were really happening. So it's not time-based. You can't say what happened yesterday morning or this morning at 3 a.m. to 5 a.m. You can't go back and find that in the DMV objects. So you need to use other tools. And there's some out there, especially in 2012 now and above, you've got extended event sessions. The system health will actually gather weights and queries and actually show you where you're waiting on the most. The system health default session, if you haven't looked at it, I would say go there and look at it, because it actually is going to show you the SQL's running, the wait types that each SQL is actually using, and actually it has a duration field that you can sort and gather that information really quickly. SolarWinds, also our database performance analyzer, is another one that actually shows you trending of SQLs over time. And I put this little picture of the Department of Motor Vehicles because I got my license here last year, but I had to wait. I went in at 3 in the afternoon, and I think they locked the doors at 5, and we didn't get out of there till 7 to get my driver's license. So that's a different kind of problem, but unfortunately I wish they could fix. Here's just how quickly response time tuning data you can get to the problem. And this actually came from a customer. He was proud of himself. They had people complaining every morning when they were coming into work. Basically, they just log into this application and go to the break room. And so they actually use DPA, and this is the response time that we're looking at, where we're looking at a 24-hour period here from 12 a.m. to 12 a.m. the next day. And what we're seeing here is each color here is a unique SQL statement. And he started looking at it, and you can see that about 1 a.m. in the morning, basically, the batch job started, and you can see there's like maybe 4 or 5 SQL statements. They're really taking a long time. I'm just going to see if I can zoom in here a little bit so you can kind of see, and I can kind of point that out to you. So you can kind of see that, whoops, let me do that again. So you can kind of see here, it started at 1 in the morning, kind of went into the 8 a.m. time frame. Actually, it completed. You can see these top 4 or 5 here. Actually, 4 completed in the 10 a.m. time frame. These little green bars here represented the people coming in trying to go to work. And you can see they were competing for resource on this box. So they got to looking around, and you can see the bottom chart here is showing the wait types it was waiting on. And so it was waiting on quite a few wait types, but primarily most of the time, in fact 5 hours, almost was spent on page IO latch shared. Now, if you go to the manuals, what page IO latch shared is saying is that it's doing a disk to memory transfer. And so it was doing a lot of disk reads. And typically it uses an index, and it points to an index problem. So that's what they did. They noticed that right away. And what they found out is not only did they have a non-selective index, but a batch job that had been running to prune the data actually was they had a maintenance and didn't put it back or something, and basically the data was growing and growing. So after they found and fixed all that, you can kind of see what the results was. Here's the before. The executions, about 35,000 or so, chunking away there until the 10 a.m. time frame. After they fixed it, they got 110,000 executions in 1 hour just by changing an index. That's how quickly you can change and tune things with response time. Notice before it was waiting on page I latch shared primarily. Had some latching going on too, probably because of the sluggishness going on there. And you can kind of see after they tune it, now it's on memory and CPU. It actually was doing actual work and getting it done. So just kind of a great picture to show the benefits of using response time analysis. Here is just a quick question I have for you to think about is which scenario is worse. You have one SQL statement executed 1,000 times, caused 10 minutes of wait for an end user, and it waited 90% on page IO latch shared. Or you have statement number 2 that executed once and caused 10 minutes of wait for an end user, and they waited 90% on a lock. Which one's better or worse, would you say? And the real answer is they're both worse. So, that end user doesn't care typically what he's waiting on. He waited 10 minutes. But I often ask this in my real-time class or in live audiences, and I get different responses. It's interesting. The developers usually say the lock is the worst. Because it could, be more than a tuning problem. It could be a concurrency problem. Okay, we've found our SQL that we're going to tune with response time. Now, what do we do with it? And the first thing I do is gather baselines. And how, I figure out how long it takes now, and I talk to my end users to find out what is acceptable. And the reason why I do that is because I want to maybe set expectations. If they've got a SQL statement that's taking 10 minutes and they want it sub-second, I can probably do that. But if something is running 10 hours and they want it sub-second, they might be a more than just a tuning problem. It might be a design issue. I also at this time take baseline metrics of logical I/O. Now, like I said, I like logical I/O because every SQL statement has to do at least one. And I take that baseline because I want something to compare against when I tune. Not only do I want to reduce the time, but I also want to reduce the resources that are being used up and waited on. So if I'm doing 1 million logical I/O reads now, I tune it, and all of a sudden I'm doing 10 million logical reads, then no, I didn't tune it. So that's kind of a neat baseline to compare against. I also collect the wait type information, and the reason why is because each one of these give me clues on where to start. Now, if I have an I/O problem, I'm going to focus on that. If I got a network problem, I'll focus on that. Each one has a different clue, and a lot of times each SQL statement will have multiple issues, and so you start working on the one that it's waiting the most, and maybe that either reduces some of the others, or you start just working down the stack. You get the execution plan. Now, the execution plan, SQL Server uses many ways to do that. I always get the actual plan. I never get the estimated plan because it could be wrong for many reasons. Even the actual execution plan may be wrong, especially if you've got it running it in production and you take that SQL and you bring it back to a development box, with different data sets and different, different hardware even. It could be wrong in development or test. But I always include the actual plan. You can do a Control-M or you can just select it on the menu. And I always set I/O time on and set statistic time, I/O time on, and to be able to get the statistics for I/O and the amount of time it takes. Then you can also trace. And now tracing has been deprecated, or they've announced it's been deprecated in 2012. It's still there. It's still there in 2014. But you can trace. It'll give you all kinds of good information. In the earlier versions, you had to trace. 2000. You could do in the performance, you could do execution plan, or you can show plan XML in 2005 and 8 and on up. I like the graphical plan, so that's usually what I use. It works when you know the problem is going to occur. Problem is with tracing, you just get all this data, and it's a little overhead, so I wouldn't recommend doing that. Instead, I would go get, use the DM table value function here, DM exec query plan, where you can go get the cached plan already in memory, so you can get the actual plan that SQL Server is thinking about using because it's cached. I think the next slide, yeah, we have it here. So this is a table valued function where I'm selecting star from sys.dmExecQueryPlan, and I pass in this raw binary, which is basically the plan handle. And notice there's no quotes around that. If you put quotes around that, it'll give you a funny error message. It won't say don't put quotes around it. So just realize you just get past it that number, and what it'll come back with is the execution plan, this graphical execution plan. Now I just grabbed something out of DM exec requests, the plan handle. So I didn't really look what I was grabbing. This looks like it might be a system query. It actually states the query here, and then it gives you the plan down here. Now, when you read execution plans, what you usually do is read right to left and bottom to top. So you can see, we start out with an index clustered scan, a clustered index scan, and then I kind of truncated that off. But what I often do is I'll look for costly steps, and you can see the actual number doesn't really matter, but most of mine are 0. I've got one that's 2, and I've got one that's 20. Clustered index scans are really table scans, so that one would be one that you might want to look at and see if you can tune. After you look at the execution plan, you find the expensive steps, then what I would do is get the table definition, for the expensive steps. First off, is it really a table, or is it a value, or using a table value function? And you can see that in Management Studio quite easily just by hovering over the table in the select statement in Management Studio, and it'll tell you whether it's a view or a table function. I also believe it's important you know where that table resides. Where does it physically reside? Make sure it's not sitting with log files, it's sitting in a data file someplace, it's not on a busy disk with a lot of other things server. Review your keys and your constraints. Know what the foreign keys are. Know what the connections between the tables. Also review the size and selectivity of the columns, especially in the where clause, because they're going to filter and drive the query. So you want to be able to identify and quickly know whether they should be indexed or not. There's a neat tool. It started in 2008 in SSIS. It's called Data Profile Task, and you can basically in SSIS create this task and give it all the tables in your query, and then basically tell it to go out and look at them, and it'll give you all kinds of good information about the columns, the null ratio. It'll give you all the distribution, all that good information. And within the Start menu, you basically do a look at the data viewer and bring this up and quickly get that information. Also, it's important to know is this existing indexes. You can use this exact SP help index and give it the table name, and it'll come back and show you all the indexes. Know the names of all the existing indexes. Know the columns. If it's a composite or multi-column index, know which one is left leading, because that's really important. Also, I think it's important that you know if you're gathering extra statistics and what your rebuild schedules are, because that could have this, approach of performance is good one day and the next day it's terrible. Finally, get more information. Get all the row counts. This is one quick way to get the row counts. You can just select name and rows and type of the object from sysobjects and join that with syspartitions on object ID, where you're looking for a table function, a user table, or a view. And you can see here, I've got order line highlighted. It's got like 430 million rows in it, so just kind of nice to know that's my very large table. Review the selected columns. Use of, asterisk or as their scalar functions, which might be slowing it down. Look for performance degraders. Case, cast, convert, all are functions that's going to take time. So if you can avoid using those, please do, especially in the where clause where you might be turning indexes off. And then also try to avoid subqueries. If you can restate it not in a subquery, you know, it'll help SQL Server. Okay, so let's review. We actually found our SQL by using response time analysis. We actually went and gathered our metrics, you know, baseline metrics. Then we looked at the execution plan, and then we gathered all information on the expensive steps in our tables that are in our query. Now it's time to tune it. Okay, so what do we tune it? And that's where I like to use SQL diagramming. And it's best to try to show this in case studies. So just to let you know a little bit about these case studies, they came from our customers. I've changed them a little bit to kind of work with this whole presentation, but they were actual customer cases. So the first one deals with a university, and really what they were trying to do was answer who registered for a class yesterday, and that, you know, they ran this for billing because they used it to bill their students. I changed it a little bit and put SQL tuning here, but they were actually passing class names through this as a parameter. But what we're doing here is we're selecting first name, last name, sign-up date from student, and then we join that on registration on student ID. Then also we join a class on registration on class ID. And we're looking where name equals SQL tuning, class name. And then we're looking where registration date is yesterday, if you will, because the dates were being passed. And then they had a canceled flag. And so we're looking where canceled equals no. This was a historical table. They never deleted out of it. If a student dropped the class or, you know, canceled coming, they just marked it as wide there. So it was a historical table. When I ran it on my laptop, executions, my metrics there that I gathered was 17,910 logical reads, and it took 1.5 minutes to execute. And what was its wait type? Well, primarily a page IO latch shared. So what does that tell me? It tells me I'm probably going to deal with an index. We go get the execution plan, and so here the execution plan, as you can see, my costly step here is, and I'm just going to zoom in so I can kind of come up here and actually point here, and my costly step, is basically this clustered index scan, 87%, you know, and then we do a clustered index scan into class, which was two scans, which then we threw it into a hash match, and then that result set went into nested loops with a clustered index seek in the student. So that's how that's going to be resolved, and nested loops to get to the final end result set. Now, notice what Management Studio says. It says it recommends adding a non-clustered index on registration, canceled, and sign-up date, and includes student ID and class ID, so make it a covering index. Question here is, well, how do I know I should do that? Well, I always like to look at, you know, what the optimizer thinks it's going to read. And so we look here and we see estimated number of rows. It thinks it's going to have to read for that costly step 3,891 rows. I also like to look at the estimated IO cost, you know, 12 and a half there, or 12, yeah, basically IO cost, and then 1.9 or 2 for the CPU cost. So just those are little things I like to look because I want to see if I improve that, you know, after I tune it. Well, how do I know I should add that? Let's go to the Tuning Advisor. Now, there's a Database Engine Tuning Advisor in Management Studio where you can plug your query in, and it comes back and gives you some recommendation. Well, even within Management Studio, it told me to add that one index, but this is telling me to add 2 indexes. And it's saying, you know, add an index on name and class ID and class, and then also add index on registration, class ID, canceled, and sign-up date. And then, oh, by the way, we want you to gather more statistics. And so gather these statistics. So what do I do? Because I've got conflicting things telling me to what to do. So that's why I like the SQL diagramming. It gives you a little scientific way to just think about what's the best way to go after that data and get the best execution plan. If you haven't heard of SQL diagramming, great book out there called SQL Tuning by Dan Tao. I've never met him, but I do like the book. It does go through SQL Server. It has, I think, Oracle as well as maybe Sybase and DB2 tuning stuff too. It goes beyond just SQL diagramming, but he gets quite quite comprehensive on the diagramming. But really what it is you're drawing upside down trees. I'm taking of my query of the tables, and I take the detailed table, or the one with the foreign keys, which is registration, and then I draw these links out to my lookup tables. So in our case, we had one lookup into student and then another lookup into class. So with that said, my join criteria is we're saying for about every one student, there's probably about 5 registration tables, and the reason records, and the reason why there's probably about 5 is 5 hours of class is probably average for a university student. And then we're saying for every one class, there's 30 records in the registration table. So, we're saying that's about the class size. So, in other words, when you join these tables for a student, you should never have to read more than 150 records. Or for one class, I should never have to read more than 150 records. So that's just kind of gives your join criteria and what you're doing when you're joining. Now the little numbers on the side here that are underlined are basically the filtering criteria. And we had 2 filters. One is we select count. One was when registration where canceled equals no and sign up date equals yesterday, if you will. And then out of that filter, we had 64,112 records come back out of 1.7 million or so. So our filter on that was 0.036, or round up 0.04, or 4% of the table is going to be read with that filter. So that's the way you can look at that. Now we had another filter on class where name equals SQL tuning. We had 2 records come back from that out of 1,267. That one was a better filter of 0.001, or 0.1% of that table would be read coming back. So that's more selective. So I really want to drive with class, and if you think about it, we were driving with class, except it was going into registration at first. So let's actually see what our relationships are with this. And we can see registration has a primary key. They all have primary keys and nothing else. They have lookups into foreign keys into class and student, but no other indexes. So, and there's definitely not another index on class name, and that's where we want to drive the table. So let's put an index on class name. And when we do that, and what happens? Well, you can see here it didn't use the index. Why would an index scan still occur on registration? It still thinks it's going to read 3,891 rows. Basically, the cost is 77%. It's still the same amount of logical reads. Nothing's changed. Why would that happen? Well, basically, we had an index on registration, but it wasn't class ID. It couldn't use it because it's the middle of that index. And so it had to read the whole index, which is a clustered index, so it did a full table scan. So let's go add an index on registration for class ID, so we can have that. And as you can see here, the execution stats show that we did fix it from 17,000 logical reads to now 266 logical reads. As you look here, it thinks it's going to read 4 rows now, and look at my I/O cost and CPU cost. Now, it's 0.00 something, so it's off the charts there on that. So we did tune it. We can see that it is using that Regel index that I added and using class name. So they're doing index seeks instead of clustered scan. We did introduce a key lookup, and that is kind of costly at 32%. So let's see what we can do with that. Let's actually add a covering index for that, so it doesn't have to do a key lookup. So instead of just on class ID, I've created an index Regel to recreate it on class ID and included sign up date and canceled, so it didn't have to do that key lookup. And what that amounted to, instead of 266 logical reads, got it down to 20 logical reads, and couldn't even get it to register in the time it took to go. And you can see how the cost has really gone down. There. Alternative, let's take everything off and do what Management Studio first said to do without doing the database engine tuning recommendation. And so I deleted everything and reran it, and you can see I did leave class name on there. So it is still driving that, which probably, I don't know if I would have gotten that a good of return if I had left that index on there. But as you can see, they said put it on cancel date, sign up date, and include student ID and class. Notice though, the optimizer thinks it's got to read 3,700 records, so it's, and actually the I/O came up a little bit too in cost. So to me, my take on it is this probably wouldn't scale as well as the one that I got with SQL diagramming. Okay, this next SQL statement, current paychecks for specific employees came from another customer, and I thought this one was a little bit strange because they're actually trying to get the last month's paychecks. They selected first name, last name, description from employees, joining on location ID, and then they're looking for first name equals first name or last name equals last name. That's what I thought was strange, because why would you just pass a first name? But that's the way the code was written, so I left it. And exist. They were looking into wage payment because they had this wage payment table that they were correlating the employee table with, and they were looking for the last 30 days. Now, it is a subquery, and my first thought was, well, I'll rewrite it. Unfortunately, the data didn't support that because they wanted only the first name, last name. They didn't want duplicates, and what was happening is wage payment, they got paid weekly, so when they were looking for the last month, that didn't support joining it because you got too many records back. But our execution stats were 64,000 logical reads. When we look at the execution plan, we can see here costly step into wage payment. 85% was the cost, and then it put that into a table, a spool, or a lazy spool because it knew it was costly. We also, we're doing a scan up here on employee. 4%. This was a seek on location, so that looked okay to me. Then finally, we went into nested loops, and once we get that result set and the lazy spool done, we threw that into another nested loops to get the end result set. Again, it's saying a missing index here. Wage payment, a pay date, include employee ID. Well, if we go draw it out, basically our tree is pretty straight. Our detail table, wage payment, is basically a lookup table into employee, which has a lookup table into location, So it's kind of a straight table, as you can see. Here we're saying the join criteria is about, for every one location, we have about 1,000 employees, and for every one employee, we have about 90 paychecks in that wage payment table. So that you should never have to join more records than that for any one of these that you're looking for. Our filtering, we had a couple filters. We had one on wage payment where pay date is last month, if you will. From that filter, we had 40,760 rows come back out of 1.9 million, if you will, or 0.02 or 0.2%. Or just 2% of that record or that table is going to be read. The other two filters was on first or last name, and the way I did this is I just took the top 5 first names and counted them, and just took them, and I had 12 like names out of 23,790, and then I turned around and did the same thing for last name, which had 22 like names. So I just kind of did the math on that, and the ratio was 0.05 or 0.09 on first or last name. So anyway, 0.05 or 0.09% was going to be read of employee table, so more specific. So I really want to drive the table by employee. So let's go look and see if we have an index on first or last name. And we don't. We have, let's see, in index, we have wage payment. We have a couple indexes on there, but there's our stuff that we're looking at. Let's create an index on last name and first name, and you see it uses it, but the problem is it can't use it to get into the wage payment. You see here, we'll query in there to see that. Okay, so clustered index scan is still 88%. We're still doing that lazy spool. So which index should we use? So we do what Management Studio says, well, that caused 50,000 logical reads, or to create a better index, let's put an index on wage payment on employee ID, because it doesn't have an index on employee ID right now that it can use. So if we put that and then put pay date on there, we get it down to 46 logical reads. So just real quick on how you can find the best execution plan. Oops, sorry, I didn't mean to get out of there. Okay, our last case study deals with lookup order status. And this was for online orders, and basically they could call in, and so this query was being run to do get the order ID, the last name, the product ID and description, the actual ship date, and the ship status and the expected ship date. So that was coming back to report to the customer. Now, how we were doing this is and made it a little more meaty because it has more tables in the join for SQL diagramming, but we were selecting from order, we were joining that on item on order ID, and then we were joining order on to customer with customer ID, and then we were joining shipment details on shipment ID to item shipment ID, and then we joined to product on item product ID, and we joined to address with the shipment detail address ID. So you can kind of see it's kind of a little complex one. And then this one also had where last name like and first name like that. So I just basically took that off and just did last name. I could have considered both first and last name, but just to shorten it up here. And then we're looking for order date within the last 30 days, and we're looking where shipment status does not equal C for completed. So execution stats on this were 10,000 logical reads, 10,159 to be exact. And so let's look at the execution plan. Again, our busy step here, we're doing an index scan here into order of, that's a high cost. We also have kind of a high cost of shipment details, but I'm going to try to actually, let's diagram this one out and see where we should drive this table. And so you can see we had quite a few filters on this. Notice I don't have any join criteria. The reason why is if you index your join columns in the where clause, make sure they have indexes, and make sure those indexes aren't being turned off by using functions or, you know, however that it's actually using the index. The join is going to be okay. You don't really have to figure out the join criteria. You can see kind of drop that step, and this is why I don't have it there. It's really the filtering criteria that you need to look for in order to drive the query. And so as you can see here, I had several filters. One was on last name from customer. I used Smith, that's my mother's maiden name. And you can see that 0.03 or 3% of that table is going to be red. On order, we had, looking for last 30 days. That was 8% of the table was going to come back. But we were also looking where order status not equals C, and 0.005 or 0.5% was going to come back. So this one is the best filter on order status. Here you can see our diagram. I think it's important that you actually diagram. It's easy enough to do in Management Studio to diagram the tables in the join. And the reason why is, I've seen this happen where you may get the correct result set, but you don't use all the join columns. And so you may have a reference that you needed to include, and somehow you've left it out. And that will change the execution plan if you do that. Also, be aware of data skew problems. And the order status column that I've called ship status here, basically it was skewed data. Only 0.5% of the rows were not equal to C. So only 6,900 of them out of, it looks like about, we got 800,000 or more. So this is data skew. And so can we fix that by, maybe not putting it by, making it equal to I? No, that's SQL Server will actually make that decision for you. But let's try adding an index on order status. What you'll see is SQL Server does do a fairly good job of handling data skew. So we put an index on order status, and I include order ID and customer ID. And I really actually got rid of the order here. the clustered index scan on order, and the high cost is now 30, or down to 0. It was 30. I still have more work to do because this shipment detail is up to 77%. So I don't have a filter on that. So we might have to get more creative and maybe include some clustering, some covering indexes on that as well. So executions, though, did come down. Out of the 10,000 it was doing, it did 300,000 now. Okay, so that's our case studies. That's just a little quick tour of using SQL diagramming. But the final step is to monitor. Monitor the improvement. Once you've tuned it, keep monitoring. Be able to prove that the tuning made a difference. Take new measurements now, because you might have to tune that query later on as well. Compare those measurements against the initial readings, and then brag about yourself, because no one else will. Also monitor for the next tuning opportunity. Tuning is a repetitive thing. As data grows, workloads change. Even if you tune and add an index here, that index may slow down other things on another side of the application. So it's always good to monitor to make sure that you're tuning the right things. And also, download our tool. It's DPA can quickly help you tune things as well. In summary, tuning queries can give you the biggest bang for the buck. Make sure you're tuning the correct, working on the right thing, the correct queries that are really slowing your end users down. Use wait type and response time analysis, to find those queries and get clues on how to start fixing them. Also use real execution plans. Get the cache plan by using DMExec query plans. You can get the plan handle from DMExec requests, and then also consider using SQL diagramming. So it's a little scientific way to get you started in the right path on the best execution plan. And then, of course, remember to monitor for the next opportunity. That's it. Any questions?
Yes, there are lots of questions.
Uh-oh. Okay. I'm glad I finished early then.
I am too. And I'll print out I'll save the questions log and send it to you. There was a question early in the presentation about, was the page life expectancy affected?
Page life expectancy affected on which, on one of the case studies maybe?
I think it was before the case studies. It was about 220.
Okay. Okay, well, page life expectancy, reason why you want to look at that, and I'll just answer, it generically. Page life expectancy is basically meaning how long that page stays in memory. And if it can stay long in memory, then chances are other SQLs can use that same data that's sitting in memory. Problem is, when you start getting low page life expectancy, you're actually thrashing memory, and what causes that is poorly tuned queries usually. When they're reading lots of data, and this is why I like the SQL diagramming, because it's going to get you to the right driving table to read the least amount of data first and then build on it, as opposed to reading millions and millions of rows and then throwing them all away at the end. Because what that does is it thrashes memory. When you start thrashing memory, basically that causes SQL Server to go to disk more, and so it just becomes this effect where you're going to have high CPU and a lot of I/O in seeing it.
Okay, we recently migrated a database from 2005 to 2012, and we are seeing some performance issues. We were typically seeing large CPU usage and memory usage. Does 2012 use more memory than 2005?
It's probably how you've configured it. If you haven't set max memory, I'd look and see that because SQL Server will try to use up all the memory it can. So depending on how you set 2005, it may be that max memory was set, and now it isn't, but by default it isn't set. That may be causing you some issues. I really can't say that 2012 uses more memory. I would just consider maybe that your did you change the box? Is it a different box? If you've got faster CPUs, maybe it's doing less disk reads and, putting it all in memory in order to do it. But it still sounds to me like inefficient queries are probably taking up a lot of memory, especially if you've got high CPU.
And this is a multi-part question. How do you
Okay.
feel about SP who is active? I use that all the time for weights. How about statistics updates? I think that last piece is a separate question.
Okay, yeah, the SP who active is going to give you what people are waiting on. The thing is, are you sitting there running it all the time? Because you're not probably going to get a trend or anything or a big feel for, which sequels are causing. You're going to see point in time, and that's fine too. But I like to see trend over time because sometimes you got to see what's normal in order to see what's not normal and what you really should be focused on. That's another thing with tracing too. I mean, if you're looking at one point in time, you really don't have a good view of a baseline of how that typically behaves. So that's why I'm all about actually looking at response time and recording that information off so you can look at it over time and see a trend. And the other thing about statistics, I'm sorry, can you give me that last question about the statistics again?
I don't know. That seems to be disconnected from the other ones, and so I don't know
Okay.
what it's about. Somebody has asked about replacing a subquery with a CTE.
CTE. That's not telling me what that is right now. That's not coming to my mind what a CTE is.
A common table expression. They're very much they're more performant than subqueries.
Yeah, if you think that could speed it up, and if you can do that, replace your subquery.
Okay. There's been a request to have the slides available. If you'll send them to me, I'll post them.
Okay, sounds great. I can do that, Sharon.
And somebody's asked about the impact of include columns on indexes in terms of storage and maintenance.
Okay, that's a good question. Covering indexes, and when you see the include, what that is a covering index, and it really is a lot more efficient than including it inside the index. So, my last slide, I created an index. Let me go back. My last case study. Maybe it wasn't that one. There was one that I actually added the index. Okay, so create an index with the 46 logical reads on imp ID and pay date. A better way to have stated that might have been to have pay date as part of the covering. That way it doesn't have to keep updating it and all that because it doesn't really store that within the index. So, I always try to use a covering index. The reason why is because if you can cover the index, give it a covering index where it doesn't have to go back to the table. Typically indexes, non-clustered indexes, make the query go first to the index and then go back to the table to fill in the select statement, the columns and the select statements. But if you can add them, include them into a covering index, what's nice about that is that it will only do one I/O. It'll only have to go to the index to satisfy both what's in the select statement as well as what's in the where clause. So, covering indexes are a good thing usually. Of course, I don't like blanket statements. Again, so you have to, you need to tune and test when you're considering this. But definitely, they're more efficient than including it in the full index.
Okay, do high inserts affect wait times? If so, how would you attempt to tune it?
High inserts affect wait times. So if you are inserting, millions of records, the first thing I would say is, when are you doing your committing? Are you doing implicit commits? If you're committing after every record, yes, it's going to take high wait time. It's going to wait on write log. because every commit or every checkpoint has to flush to disk. And so you flush the log buffers to disk. So batch them up. If you can batch up your inserts, that's what I would do, and that would speed it up greatly.
And this is a simple question, I think. What's the difference between adding columns to the index key and adding them as included columns?
Yeah, and that's the covering index again that I just talked about, where, in this example that I've got up on my screen, you can see the top one has pay date and an included employee ID. It really doesn't, it's a different mechanism SQL Server uses in storing and maintaining a covering index with the include, as opposed to putting it in a B tree like this one. This will be a B tree index where you'd have employees, and then under employees you'd have the pay dates underneath them. So it's a little harder to maintain when you do it that way. But again, it's like I said, you have to test it to see if it's an answer for you.
Yeah, my understanding is that the included columns only appear in the leaf nodes.
Yeah.
And not all the way through the tree. So if you're carrying something big through the whole tree, it bloats the whole index.
It could depending, but how important is it to not do that extra I/O back to the table?
Yeah.
So that's the trade-off. So.
Well, I think we are out of. Nope, we just got another question. One more. This is it. This is it, guys. Top weight is CX packet. I'm still trying to understand how to fix this, or even if we need to fix it.
Okay, top weight is CX packet. The first thing I would look for is, well, first thing I would ask, is it a warehouse environment or are you doing OLTP? Data warehouse, probably parallelism. CX packet is the the master process that is more of a status. The master process is reporting it's on CS packets because it's waiting for all of its slaves to complete. So to find out if that's an actual problem or not, ask yourself a few questions. If it's a data warehouse and they're working with large data sets, CX packet parallelism may be necessary, and it's often you're going to be your largest weight. If it's OLTP, then we're basically using parallelism in a highly transactional processing state that you're really robbing Peter to pay Paul because you've got multiple processes working on one statement where you've probably got a lot of people logged in wanting to do quick transactions. So there's a couple ways to handle that, and one is to look at your max DOP or degree of parallelism. Look at that setting. You can actually play with the hint on a query and actually play with that setting to see if it's appropriate for you to be using parallelism. Some queries don't work well with parallelism, and so what I often do is I'll go look and see what the slaves are doing. A lot of times you'll get too many slaves and all of a sudden they'll start competing against each other for resource, and so it just slows it down. So I can't really answer your question about if it's a problem or not, but that's where I would go look first and consider all of those things I just said to see if it is.
Okay, thank you very much, Janice. That was fascinating. Sure. I want to look into this diagramming of the query. It's something that was new to me. I have one last thing to do, and that is to announce that our raffle winner of the $100 Amazon gift card is Shri Muley at gmail.com, and headquarters will deal with sending this to you. I don't do that. And that brings us to the end of our webinar. No webinar in 2 weeks because we'll all be at Summit. I'll see you back in November. Thank you very much for coming, and have a great afternoon.